What is statistics? Benjamin Disraeli once said, there are three kinds of lies: lies, damn lies, and statistics. It is so easy to lie with statistics. For example, with misleading graphs. Let's look at these two graphs. It seems like those two are different graphs, but both show exactly the same data. Both graphs show the days of freezing temperatures in 2007 versus 2008. However, the graph on the left makes the change appear to be much larger than it really is because the numbers on the vertical axis do not start at a zero. It starts at 80 days. Each vertical mark on the left graph represents 1, and each mark on the right graph represents 20. The scale changes. Or, for example, this graph. The graph seems to show correlation between the number of pirates, which are decreasing from 1820 to 2000, and the global average temperature increasing from 14 degrees Celsius to almost 16 degrees Celsius. So it seems like there is a causation that the decreasing number of pirates caused the global temperature increase. That's why this funny name of the graph, Stop Global Warming, Become a Pirate. I will post the link for you to watch this very interesting video, How Statistics Can Be Misleading. And then we'll discuss it in the next class. It's easy to lie with statistics. It's hard to tell the truth without statistics. Statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write, said Wells. And he was right. So do statistics lie, or is it a misuse of statistics that lie? Remember, statistics does not equal calculations. Statistics is calculations and statistical reasoning. If you take away reasoning, you're not doing statistics. Statistics is about how not to lie with data. So what is statistic? The definition of statistic is that it is science of developing and studying methods for collecting, analyzing, interpreting, and presenting data to help people make decisions when faced with uncertainty. Statistics involve the steps of preparing the data, analyzing it, and summarizing it, making conclusions. The main components of statistics is statistical literacy, which is understanding the language and ideas of statistics, and statistical thinking, which involves critical thinking and the ability to make sense of the results. Statistical thinking demands so much more than the ability to execute complicated calculations. So why statistics is important? For several reasons. We use statistics in our everyday life. Society and businesses want to have control over things like reducing rates of cancer, heart attack, other diseases, growing better plants, determining what public services announcements help change the behavior, such as smoking, drug warning, deciding whether building a new lane on a congested road will increase or decrease the congestion, releasing movies at the right time to get good attendance. As social curious beings, we want to know about other people. Who are they planning to vote in the next election? What television programs are they watching? As individuals, we need to make personal decisions like what to eat to remain healthy, cost versus benefit for lifestyle changes, exercise, meditation, taking aspirin a day, nightlife for children. As intelligent, curious beings, we want to understand things like how does memory work? Do left-handed people die at younger average age? Does listening to classical music improve scores on an intelligence test? There are two areas of statistics: descriptive statistics, which is methods of organizing, summarizing, and presenting the data in an informative way. organizing the tables, constructing the graphs, finding the measures of center and variation. And inferential statistics, which is making decisions and drawing conclusions about populations on the basis of a sample. So what is the cycle of inferential statistics? First, we want to know some parameter about the population. Population is all of the individuals of interest. Then we take a sample from that population. Based on the sample, we then make conclusions about the population. So for example, we want to find out which teaching methods are more productive in a population of a first grade children. We cannot observe every single first grader. It's just not possible. So we take a sample, we take two samples, sample A and sample B, that consist of just few first graders. And then we compare the teaching methods. And then based on those samples, we build a graphs, or we construct the tables and build the graphs. Step 3, we make conclusions based on these results. Population is a complete collection of all measurements or data that are being considered. Typically, it's a collection of data that we would like to make inferences about. Parameter is a numerical measurement describing some characteristic of a population. Sample is a subcollection of members selected from a population. And statistic is a numerical measurement describing some characteristic of a sample. So for example, population in this case would be every single car of, let's say we want to make a study about how good are the Honda cars. They say that Honda depreciation of Honda cars are really good. So we cannot observe every single Honda car. We can only observe the value of a few Honda cars. So this will be our sample. So notice population P, parameter P, population parameter, SS, sample statistics. Now let's do the checkup. Let's check how well we understand the population versus sample. In the Harris Interactive Survey of 2,276 adults in the United States, it was found that 33% of those surveyed never traveled using commercial airlines. What is the population and what is the sample in this example? Is the value of 33% a statistic or parameter? You can stop the video and think about it for a minute. What is statistical and practical significance? Sometimes we say the study has statistical significance, but it does not have any practical significance, and vice versa. Or the study can have statistical and practical significance, or neither. Statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance. A common criteria is that we have statistical significance if the likelihood of the event occurring by chance is 5% or less. Practical significance: the results have a practical significance if the difference is not very small and therefore that difference is large enough to justify its use. It's possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. Let's do the checkup. Question number 1. In a study of the gender aid method of gender selection used to increase the likelihood of a baby being born a girl, 2,000 users of the method gave birth to 980 boys and 1,020 girls. there's about a 19% chance of getting that many girls if the method had no effect. Let's think about it. Does the result appear to have statistical significance? Does the result appear to have practical significance? Stop the video for a minute and think about it. And question number 2. In the study of a Kingman diet and exercise program, 40 subjects lost an average of 22 pounds. There's about 1% chance of getting such a result with a program that has no effect. Let's think about this. Does the result appear to have statistical significance? Practical significance? Stop the video for a minute and then let's think about it. The answer to number 1. The result do not have statistical significance because 19% chance is large, much more than 5% of getting it by chance. And the difference is only 40 babies between the number of boys and the number of girls, which appears to be small among the 2,000 users. Therefore, the results do not have practical significance. And number 2, because the chance of obtaining these results is only 1%, which is less than 5, we can say that they have statistical significance. Also, the average loss of 22 pounds appears to be large enough, so the results have practical significance. I hope you learned something about statistics today, and we'll continue learning.